All right, going through this review for Unit 1. Begin with the question asks, which of the following position versus time graphs shows an object that is moving at constant velocity? Remember that constant velocity means that the speed isn't changing, and this is a position graph. So it means that the slope should be constant. That means a straight line. So both A and D have straight lines, right? So velocity is constant when the slope is constant or it's a straight line. For number 2, which of the graphs shows an object that has unbalanced forces acting on it? Unbalanced forces means that there's a net force or there's a force that is not being canceled out, and so an unbalanced force causes acceleration. So which ones show acceleration? B and C show unbalanced forces. Since they have acceleration. Right, a curve is acceleration on a position graph. Okay, moving on. For number 3, for each of the following, state the net force is, and if the forces are balanced or unbalanced. To get the net force, you just have to add or subtract all the different forces together. Right, so if you have 3 forces, you just add those, or add how many forces you have. To the left will be negative, to the right will be positive. So in this case, for the first one here, this force would be negative 4 newtons. And there's no other force, so that's the only force, and that would be our net force. This is unbalanced because there's no force to cancel it out. For the second one here on the right, you have 4 to the right, 4 to the left. So you'd have 4 positive and then 4 negative. And this would be 0. This would be balanced, right? Because you have the same forces on opposite sides canceling each other out. Next one, you have 6 to the right and then 3 to the right. So you have 6 newtons plus 3 newtons. This would be unbalanced because this is going to be a total of 9 newtons, right? There's 2 forces to the right and nothing to the left. And for the last one, you have these 2 forces to the left, so you have 2 negative forces. And this ends up being negative 6 newtons. This is also unbalanced because there's nothing balancing it out on the right side. So out of these, the only one that's balanced would be the one that has a net 0 force, okay? So net force has to be equal to 0 in order to have balanced forces. For number 5, question is, the graphs represent data taken from a Newton's second law experiment where the mass and net force were changed and the resulting acceleration measured. In the box says, add the correct labels for the graphs based on what you know about the relationship stated in Newton's second law. Newton's second law specifically tells us there's an inverse relationship between acceleration and mass and a proportional relationship between acceleration and net force. So in both of these graphs, the left side here is going to be acceleration. The one that shows us an inverse relationship, like the one with mass, would be the one on the left. Inverse means that as one goes up, the other one goes down, right? So as mass goes up in this direction, the acceleration is actually decreasing in this case, right? That's an inverse. And then the other one is the net force. Because in this one, it has a proportional relationship. It means the net force goes up in this direction, the acceleration goes up in this direction. Okay? Number 6, you have a situation like this with 2 masses and the cart and the pulley. we're supposed to complete this statement. So if the mass of m1 is increased or decreased, while m2 remains the same, the acceleration of the cart will increase or decrease. It's an example of proportional or an inverse relationship, right? So we can say that if m1 increased while m2 remains the same, the acceleration of the cart will decrease, right? If this mass here increases, the cart is actually harder to pull, and so this would decrease the acceleration. This is an example of an inverse relationship, right? Because as the mass goes up, the acceleration goes down. In the second one, if the mass m2 increases or decreases while m1 remains the same, the force of the cart will increase or decrease, and the acceleration will increase or decrease. This is an example of blank, right? So in this case, you could say if m2 increased, then the force on the cart will increase as well, and the acceleration will also increase. It's an example of a proportional relationship, because as the force gets bigger, the acceleration gets bigger as well. Okay? For number 7, you're asked to calculate the acceleration for the values shown in here. So for the acceleration, we would do force over mass, right? So we're going to take this force value here and divide it by the mass value. So in the case here, 0.24 divided by 0.8, and this would actually be 0.3. If we do the same for number 2, 0.36 over 1.2, that would also be 0.3. And then 0.48 over 1.6 is also 0.3. So if you plug in the values using this formula here, those are the values that you would get for those. For the second set, 4, 5, and 6, it turns out that if you divide these values together, you're going to get 0.8. The same is true for the second one and the third one here. So first 3 trials you get 0.3, the second 3 trials you get 0.8. Okay, so in number A, complete the statement based on the table in question 7. In trial 3, the mass of the object is compared to double or half the mass of the object in trial 1. So in trial 3, the mass is twice the mass of trial 1, so double. The acceleration in trial 3 is, so the acceleration here is the same as the one here, right? So it's going to be equal to. This is because the blank mass or force was greater than, less than, or equal to. So the mass was greater, right? But that doesn't explain why the acceleration would be the same. The force was greater, right? And that actually does explain why the acceleration is the same. Because even though the mass went up, right? So the mass increased in trial 3, so did the force. Since both of them went up, then the acceleration could stay the same. Right? If only one had increased, then we'd either get more acceleration or less acceleration. Right? Because more force would mean more acceleration, more mass would mean less acceleration. But they both went up, so it actually balances out and get the same acceleration.